Okay, I have another question there, example 3. During the electrolysis of a salt of a metal M, a current of 0.5 ampere flows for 32 minutes. A current of 0.5 ampere flows for 32 minutes 10 seconds and deposits 0.32 gram of the metal, and then you are asked to calculate the charge on the metal ion. You are given that the relative atomic mass of the the relative atomic mass of the metal is 65, and then Faraday still at 96,500. Okay, looking at it, during the release of the salts of metal M, a current, so we have I as what? 0.5, and then we have time at 32 minutes, so we convert 30 minutes, 10 seconds should be 32 multiplied by 60 plus 10. So what do I have there? 32 times 60, I'm converting 30 minutes to seconds, so I'm multiplying by 60. I think it's 90 what? Oh, okay, altogether. Added with 10 seconds, isn't it? That'll give me what? 1, yes? 1930. Is that what you have? That's the second, that's the equivalent of 32 minutes, 10 seconds in seconds. And deposits, okay. And deposits, so that is the mass it deposits, given as what? 3.2, okay, of the metal. Calculate the charge. So the charge is not given. Okay, another thing is given is RAM, which is 65, and then Faraday, which is 96,500 coulombs. Okay, let's use our formula here. M is what? Relative atomic mass times I times time upon what? C times what? F. Okay, I can even use this as small z, charge. Okay, what do? Play with this. MO is this. Okay, MO is this. So MO is 0.32 equals to 65 times what? I 0.5 times time. Time again is what? 1930 upon Z times 96,500. Okay, this is what we have. So what do you do at this point? We cross what? Multiply. This times Z is 0.3Z times this. 2,8,950. Is that it? Z, Abi, is equals to this times this times this times this. 6,2,7,2,5. What do you do at this point now? Divide both sides by the coefficients of the Z. Abi? So we have this against 289. Are you waiting me? And 28950. So this one. So Z alone is what? 2. Since it is a charge, it carries a positive what? Charge. So that's the answer. So it's 2. Finally, try this. What current will deposit 3.25 gram of zinc in 2 hours? Okay, I think what current I is what we are looking for, the current, and then We have the mass of zinc, 3.25, and then we have our time, 2 hours. So what is the equivalent of 2 hours in seconds? 7,200 seconds. Okay, that's the time. We have changed that 2 hours to seconds. That's why we're having 7,200. And the other information given is the relative atomic mass, 65. Other information given, Faraday, 96500. Other extra information added here will be charge of zinc. Zinc is one transition or forced transition element whose oscillation state is +2. That doesn't change, doesn't have variables, so that is what it is. So we can now state we can apply our formula, Faraday's formula, using M equals to RAM times I times T, what? Z times what? F. So we plug in these things here. So our M is 3.25. Or we can say, what are we looking for here? I. You can say I equals to what? MZF. Are you there? MZF over what? RAM times what? Times T, isn't it? Times T, correct. So what is I? What is M? 3.25 times 2 times 96500 upon what? 65 times what? 7,200. So what do you have as I now? 1.3 what? I think 1.34. Make sure your answers are always in 3 significant figures. 1.34 watts amperes.